Hi you guys, in that last video I had you learned about similar figures and scale factor, and in this video we are going to learn about similar figures and scale drawings. So the very first problem says Jessie is using a map to travel from her home to the state capitol. She measures on the map to find the route is 4 inches long. The scale of the map says that 1 inch is equal to 20 miles. How could Jessie determine the number of miles she will travel to the state capitol? Okay, so when we are looking at this, the question we're being asked is, how could Jessie determine the number of miles she will travel to the state capitol using the scale of the map? Okay, so the scale of the map says that 1 inch is equal to 20 miles. So if you got out your ruler and you measured the distance on the map using a ruler. Okay, so let's go ahead and write that scale of the map as a ratio. Okay, so 1 inch, oh, I don't want to do it in yellow. Let me do it in black. Okay, so 1 inch is equal to 20 miles. So when you are using scale factor in scale drawings, when you're using a scale, you have to make sure that when you write your ratios, you write them with equivalent units matching up in the same place. So I'm going to show you what I mean by that in just a second. So the scale of the map is that 1 inch is equal to 20 miles, and she measures on the map that the route that she needs to go is 4 inches long. So we want to answer the question, how could she determine the number of miles she will travel to the state capitol if she measures on the map and the distance between them on the map is 4 inches? Okay, so what we do is we're going to set up another ratio, and what we know is that the distance to the state capitol is 4 inches from her home, and what we want to know is how many miles is that going to be. Okay, so we're going to use the idea of creating equivalent fractions. We basically need to find the scale factor of how we get from 1 inch to 4 inches, and then we're going to use that to help us know what we're going to multiply by to get to the number of miles. Okay, so to go from, so we want to create equivalent fractions. So to go from 1 to 4, we're going to have to multiply by 4, which means the 20 is also going to have to multiply by 4, which ends up giving us 80 miles. Okay, so we were able to use the scale of the map and what we know about scale factor to figure out the number of miles she's going to travel to the state capitol. Okay, so let's go to the next part. Similar figures have corresponding side lengths that are proportional. When two figures are similar, a proportion or equivalent fractions, the idea of equivalent fractions can be used to find the length of an unknown side. So if we have this figure right here, we have two triangles. We know that this side right here, AB, we know that on the smaller similar figure that it corresponds with this side. And then we know that this side right here, BC, on our smaller figure, it corresponds with EF. We know that we're going from a bigger figure to a smaller figure, which means our scale factor is going to be a fraction, right? We're going from bigger to smaller. So what we want to know is, what are we multiplying by to get to our new side lengths? Okay. Now, when you're setting up your ratios, you have to make sure that you do them the same. Okay, so I'm going to go red over green. Okay, so the height over the base is equal to red over green. Okay, now I want to know what I'm multiplying the 6 by to get to 4, and then I'm also going to multiply the 8 by that to get to x. So we're going to say 6 times by what number gets us to 4. And then remember that in order to figure out what n is, Because the n is being multiplied by 6, we're going to use division. So divide by 6 on both sides. So our n is equal to 2/3. So if I take 8 and I times by 2/3, that is going to give me this new side length. Okay, let's try it with trapezoid. It says trapezoid ABCD is similar. Anytime you are given information that two figures are similar, you know that there is a scale factor involved, because if they're similar, their side lengths are proportional, which means the ratios of their corresponding sides are equal. Okay, so we want to know what the length of RS is. So this side right here on the trapezoid, it corresponds with this side. And then this side right here on the trapezoid corresponds with this side. Okay, so when I set up my ratio, I have to do it so that we're talking about the corresponding sides. So I am going to say red over green is equal to red over green, and that's what I don't know. Okay, so now I just need to find the scale factor. What are we multiplying 1.7 by? So what number are we multiplying 1.7 by to get to 5.1? And then once I know that, I'm going to multiply the 2.8. I'm going to multiply that by the same number to get to the green side length. Okay, so if I have an equation that's 1.7 times by n, to get rid of that multiplication of 1.7, I'm going to use division, which I do on both sides. And if I take 5.1 and I divide by 1.7, I get a 3. That's my scale factor. So that means that I'm going to take the 2.8, I'm going to times by 3, and that is going to give me 8.4. All right, let's do another one. And actually, we're going to go ahead and skip this one. So just go ahead and skip that one, and then let's go to the next one. Let's skip that one too, okay? Just because I don't want these notes to take forever, and I need to get moving to the models part. Okay, the photo below will be enlarged to form a 16 by 20 print. What is the scale factor needed to enlarge it? Okay, so we're going from this smaller picture to a bigger picture, right? I'm going to go to a bigger picture, and it said it's going to be enlarged to a 16 by 20, and we want to know what the scale factor is. So let's take our height right here, right? Our height is 4, and then our base is 5. So let's do height over base for our ratio. Height over base, which means that we are going to do height, which is 16, over our base, which is 20. So to find our scale factor, we're looking for what are we multiplying the 4 by to get to 16, what are we multiplying the 5 by to get to 20, and in both cases, we know that that is 4. 4 is our scale factor. Okay, let's do a couple more, and then you guys are going to be ready to do some problems on your own. A tree casts a shadow that is 9 feet long. So we have a tree. I'm not a very good artist, but here's our tree. A tree casts a shadow that is 9 feet long. At the same time, a person standing by casts a shadow that is 3 feet long. If the person is 5.5 feet tall, how tall is the tree? Okay, so we're going to go ahead and set up our ratios using our corresponding parts. So we know the height of the tree over the length of the shadow has to be equal to the height of the person over the length of the shadow. So we want to know how tall is the tree. And actually in this case, because we want to know how tall the tree is, I'm actually going to set this up as 5.5 over 3, and then we're going to do x over 9, okay? Because that's what we're really wanting to know is how tall the tree is, and we're using the ratio of what we know about the person's height over the person's shadow. Okay, this also makes it really easy for us to see that our scale factor is going to be a 3, because 3 times 3 is what gets us to 9. So to find the height of the tree, we have to do 5.5 times by 3, and that's going to be 16.5 feet tall. Okay, let's try another one. A map of the state of Texas shows one scale, the scale to be 1 inch equals 80 miles. The distance between Austin and Corpus Christi is 232 miles. How far apart will the two cities be on the map? Okay, so first thing we do is we write our scale as a ratio. Okay, and then we're going to write what we know. We're going to make sure that it matches what our scale is. Okay, so we know that 1 inch is equal to 80 miles. So we have inches over miles. So when we write our other ratio that's going to help us figure out how far apart they are on the map, we have to put miles on the bottom because we're looking for inches. Okay, so now in order to do this, we need to know the scale factor. We need to know 80 miles times by what number gets us to 232. So if we take the 232 and we divide by 80, we get 2.9. Okay, so that number is 2.9. That means our scale factor is 2.9. So if I take 1 inch and I multiply by 2.9, that gives me 2.9 inches. So if you were to measure the distance on the map, you would get 2.9 inches on your ruler. Okay, let's try another one. Susie walks 1.5 miles to school. When she looks at the map, it shows the scale to be 1 centimeter equals 0.5 miles. What is the distance between Susie's house and her school on the map? So first thing we do is we take our scale that we know. 1 centimeter is equal to 0.5 miles. We write that as a ratio, and then we fill in another ratio so that we can make equivalent fractions, right? We're going to find our scale factor. So we know she walks 1.5 miles, so we're going to have to put miles on the bottom because remember your ratios have to match. That's the tricky part about this. And then what is the distance between Susie's house and her school on the map? Okay, so to figure this out, we need to find the scale factor. What are we multiplying 0.5 by to get to 1.5? So if I take 1.5 and I divide by 0.5, right, because to solve this, I'm going to divide both sides by 0.5. That's going to give me a 3. That's our scale factor. So 1 centimeter times 3 gives us 3 centimeters. So if you were to measure on the map, and 1 centimeter equals 5 miles, then on the map, you would measure that the distance between her house and the school is 3. Okay, let's go ahead and do one more. Abby studies a map of Italy that shows a scale of 0.5 centimeters over 10 kilometers. The Pantheon and the Spanish Steps are 0.4 centimeters apart on the map. We've got centimeters on top. The Trevi Fountain is located exactly halfway between the Pantheon and the Spanish Steps. What is the distance in kilometers from the Trevi Fountain to the Spanish Steps? Okay, so the Pantheon and the Spanish Steps are 0.4 centimeters apart. So let's find out what that actual distance is, and then we can divide that by 2, because it tells us the Trevi Fountain is halfway between the Pantheon and the Spanish Steps. So first thing we need to do is find our scale factor. We want to know 0.5 times what number gets us to 0.4 centimeters. So that is when we divide both sides by 0.5, we get that number, that scale factor number is 0.8. Okay, so now if I multiply this 10 by 0.8, that's what's going to give me this missing part, which is the distance in kilometers. So 10 times by 0.8 is 8. Okay. Now it says the Trevi Fountain is located halfway. So if we do halfway, 8 divided by 2 is going to be 4. Okay, so you guys are now ready to do, come back and see me, show me your notes, and then I'm going to tell you the next thing that I want you to do. Okay,